Today we're here to talk a little about contraception, or the lack thereof. And so what we have is a very unique species, the yellow-footed rock wallaby, which none of them are out. So if you guys will, when you get a chance, just sort of walk around. We have about 6 of them in there, one male and then a bunch of females in there. So the story with them is that we're having trouble with contraception. This is an endangered group from Australia. We're trying to breed enough so that we can eventually reintroduce into the wild, but we need to build an insurance population here in the United States before we get to that point. One of the things that we find over the last approximately 8 years is we're producing approximately 59.4% males versus the rest being female. So we're producing way too many males at this point. So what our goal is to try to contracept some of the lower ranking genetic females so that they won't produce as much and we won't have as many surplus males. And as we said in the proceedings, we tried deslorelin as the contraception of choice as recommended by our SSP or the AZA. That has proven not effective at this point. Well, excuse me, it's proven effective, but effective too long. So instead of providing 1-year contraception, which is what we're shooting for, we're getting 2 years or more, and some of them have not even come back into season, which has been an issue for us. So what we're here today to talk about is what are the options and things like that. I was hoping I could snag one of these 2 gentlemen to help present and provide some other alternatives with what's going on with these guys. We have attempted to try and manage them with bachelor herds, and so you can see like we have a group. Unfortunately, those aren't all the males, but we're not finding that to be overly successful with managing the surplus males, as males get a little rambunctious and they fight each other, and just like this morning, they bully each other. So that's been an issue for us also. So as I said, right now our recommendation is to use deslorelin. And as I said, we've had mixed success with it. It does produce some contraception, but we've had some that have not come back into season, which is a problem. The really challenging thing with wallabies is that they're a very unique species in the sense that they can actually support three offspring at different levels or different levels of development. And so you can have a joey that's actually out of the pouch and nursing. You can have a joey in the pouch and is actually nursing also. And then you can have another embryo that's in the body and that hasn't come out and started nursing yet. And so the animal has a very unique physiology that allows it to put the animals into diapause, as we had talked about this morning, based on nutritional and resources that are available. So if it's especially dry and there's no food, the animal will put this animal into a diapause and it won't produce until the resources improve. I think because of that, because of the fact that it has that ability to have 3 different joeys, that has resulted in the complication with providing a very good contraception. Pierre and I were just talking a little while ago about possibly using PZP, which is the zona pellucida vaccine. It's an effective vaccine in some animals. He was just sharing his experience with that, and I don't know if I can get you to talk a little more about that, Pierre, about your experience with that and usage in wallabies. I know
yeah, well, actually,
or maybe whoever has more experience with that.
Well, no, but it's because that's something that is being tried in deer species and in wild horses, also in North East Coast, and wow. And
they also want to be on tape too.
Already?
Pierre,
the issue is that you don't. It's in order to have an immunization, you need to make sure, obviously, that you have a good antigen, right, for the immunization. And the type of immunization that's obtained with against some antigens of the zona pellucida is something that's really for wild species. I mean, for wild population. The problem is that it's not a sustainable immunization, and you need to inject a booster if you want to make sure that you're going to have a longer immunization. But then at some point anyway, it's not, I mean, it's something that doesn't last forever. And actually, it's kind of reversible, which is something that you are looking for, right?
Absolutely. That's one thing that's very critical, is that whatever we use is reversible.
Mm-hmm. And so Dave, what's the last updates about those antigens? You know, we were talking about that this morning.
Okay, so when you're looking at
the sequence of zona pellucida. So you're looking at ZP3, and that's what this antibody is made against. It's pretty homologous. So you guys know homologous. It's pretty much the same across all mammalia. You know, and what the recent studies are showing is, okay, so there's one of them. He's right up there. Is that this change is that, you know, this is developed in porcine, I think.
Yes, porcine.
Yeah, porcine. So that's, you know, eutherian mammals, and these are obviously marsupials, so they're highly divergent in terms of speciation. And that creates some differences in the amino acid sequence. So on the whole, when you look at the amino acid sequence of these zona pellucida among these mammalia, it's about 83 to 95% the same. However, when you start looking at what the antibody was raised against, so you can't take that whole thing and raise an antibody against it. You have to take a single part of it, present it as an epitope in which the animal recognizes not itself, and then it builds up antibodies against that. Well, then we start to lose some of that homology, and then we're starting to look at around 35 to 50% homology in terms of what the antibody is actually being raised against. So it is effective, and like Pierre was saying, in some mammals you can do a single shot, and well, you know, it's pretty much homologous among that, and you're going to get a good titer to that one administration. But with these guys, when we're looking at a very small recognition of the zona pellucida antigen in these guys, is that it may require successive doses, and even then we don't know if it'll be successful.
Right. We have used the PZP in giraffes. I know of that. We've used it in giraffes, and we've used it successfully to the point, though, that we've had to give it once repeatedly in 3 weeks. And it was supposed to last a year, and we didn't get a full year. And this is when I was in Phoenix. They actually had a calf at about, I think it was about 9 months after the last injection. So we know that not in all giraffes it's going to last. And I think that's very consistent with the comment that you just made. Mm-hmm. But we do use PZP also in other hoofstock species very successfully, without problems, and only having to re-immunize them about yearly.
Okay. But can you tell us a little bit more about what was the protocol for the
desloranin? We actually have no protocol for it because we've not been successful with it. And so I know another zoo in the country has actually just started a reproductive contraception study in we're using.
In the Wallaby? In the Wallaby?
In the Wallaby, it's a Lowry Park at Tampa. I don't remember which they're using. They might. I'm not sure if they're using MGA or not. They're using a. They're doing a study over at Lowry Park. They've just started that, and they're going to be using 2 or 3 other type of contraceptions, and which ones they're using, I don't recall. And I don't know any of the details of it. I was just informed of it. But I mean, the big thing is just, you know, trying to come up with other alternatives in terms of contraception for these guys. I don't know if there are any human OBGYNs out there in the audience. No one? Man, we're supposed to have some OBGYNs.
Well, I mean, if Dr. Silver was here, I can talk on his behalf. He would tell you that why don't you use vasectomy in the male, because he's convinced that vasectomy can be reversed in some cases, which is true, by the way, because he did that for one of our P-horse, Przewalski horse at the National Zoo, reversing a vasectomy. But so that could be one option also. Yes, absolutely. Vasectomy would be one option that we would consider, although historically we've always considered vasectomy to be a very risky procedure in the sense that if it's not reversible, you don't know until you do the procedure, try to reverse it, and it doesn't reverse, and then if it doesn't reverse, then you're sort of in trouble. You have no other options at that point. I believe at this point, based on what Sherman said this morning, though, vasectomy is now becoming a more reliably reversible procedure.
What about banks of frozen semen and then vasectomies?
I don't believe, to my knowledge, with Wallaby that we've gotten to the point where we're able to actually obtain the semen and freeze it reliably long term. So at least not that I've heard of. I haven't heard of any studies to be able to do that.
I don't know. No, you're right. Marsupials sperm, no, never heard
Yeah.
of.
I think the big thing with regards to what we deal here at the zoo in terms of contraception, in terms of the species, is that we look at trying to match the most genetically important animals. So in here we might have the #1 genetically valuable wallaby in the country, and he might be slated to breed, say, #2 genetic female, and so we'll want that mating to occur. But in that cage may also be #12 and #14 female, which we don't want that breeding. And that's why we look at contraception as the way to go, to just contracept the females we don't want, yet allow them to be in a social structure that is very similar to what they're going to have in nature. The thing that we don't want to do as much as we can is to pull any one animal away from the herd of them, because it is different. They're a social species, and so we always want to keep them together, as we had talked about earlier this morning with that. So that's really the story behind wallaby contraception.
You want to talk about how Deslarelin doesn't work?
Yes.
I don't know why it doesn't work.
No, but what did you do with the Deslarelin? So you put the implant for how long?
We placed the implant with the expectation that they would come back into season within a year, and they never did. And so I think we did four total animals. One of them actually passed away before she could come back into season. One of them took more than 2 years. One of them never came back in, and one of them we're waiting to see. So that's our experience with it.
So what dosage? I mean, the full implant that you put in each animal?
No, we use it comes in 2 sizes, and we use the smaller of the 2.
Okay.
I forget exactly the milligrams of that.
Okay, but that's the small one.
Yes.
Okay.
Mm-hmm.
Okay.
So I'm not exactly sure. I don't know the pharmacology of it. So
I don't know the pharmacology, but I mean, do you guys know what Deslarelin is? It's a progestin. So in other words, it's a progestogen analog. So when we were talking about that, what's that going to do to the ovary? Well, it's going to shut down the ovary in terms of follicle development, but that's not occurring directly at the site of the ovary. That's occurring higher up here at the hypothalamic level. And basically what you're doing is you're shutting down the feedback to the ovary that's saying promote follicular growth. And what I don't know what's been really demonstrated in terms of Deslarelin and this long-term effect is for the long term, if it causes kind of a quiescence up in the hypothalamic pituitary feedback, such that even pulling back the Deslarelin, that the hypothalamic pituitary is able to rebound from it and reignite and become producing these steroids. I mean, not steroids, but the hormones that drive follicular development. So that's.
But I think when we did this, we were under the impression that the rebound wouldn't take that long, and so we could pull it, and definitely within a couple of months, the animal would start going back into season like it usually was.
And that's what they showed in 2007. They did a study in 2007 that showed that you administer this Deslarelin, and then within 6 months you have recovery of the animals, and it's fully safe, and there's no uterine pathologies.
In wallabies?
Yes. Now, I'd have to go and pull the papers from Marilyn Renfree.
Yeah, but that's the same wallaby. That's the Tama wallaby.
Well, if it's the best analog that you have in terms of. So we don't know if it differs from wallaby to wallaby, even from rock wallaby to rock wallaby.
Well, I do know there are multiple different species of wallabies, and so the contraception used in wallabies will vary. Like I think Bennett's wallabies, I think the Deslarelin is a little more predictable. So we have found that it hasn't been predictable in this species. So the question is, what other contraceptions would you recommend if we don't go with that then? I mean, we talked, PZP is one option, but what are the other ones that you would
What
think
about, I don't know, endocrine disruptors or stuff like that you soy milk in the diet?
Yeah, there's when we talk about these species-specific mechanisms, it's really tough to say this is going to be your one true shot. I'd have to go and do some more research on it.
So we got the next study here. This is our next study. Thanks, Chris. Are there any questions about this? Unfortunately, we don't have any answers for you here. This is, again, something that we're dealing with and trying to figure out. Yeah, Natalie.
If you're breeding like if you don't want to breed number like 12 and 13 female, why do you even want it to be reversible in the first place?
That's a great question. So why are we worried about number 12 and 13 on that list when we don't want to breed them? The reason we do that is primarily we don't want to use anything that's non-reversible in case there is any mishaps, any problems. So if for some reason number 1 through 5 we have to spay her, or she has cancer, or she dies from other reason or whatever, number 12 could easily become number 3 or 4 within 2 years. And so that's why we always look at reversible contraceptions or means of not letting them breed.
And also, do you use the same contraceptive on kangaroos?
I believe they do, but I have to admit I have never had to contracept a kangaroo, so I don't know that for sure.
I think they do recommend Veterinarian for kangaroos.
I think it's the general recommendation for all marsupials right now, if I'm not mistaken. Yeah. Yes?
So is the main problem that you have too many male individuals or too many of both genders?
Primarily our problem is too many males. That's the main thing. And so when we look at producing more males than females, the more they produce, the more males we have to deal with as surplus animals. And right now we're able somewhat to provide homes for a majority of these males. We're just trying to minimize the number of times that we have to move a male because we don't have a home for it here.
So how many females can a male breed? Breed a lot of females?
Yes, this male has been very productive with 5 females with no problem.
So how come you don't have just vasectomy some of the males so they're or even neuter them so they can live together and keep some of the highway females?
Again, it goes back to what we were saying, that if for some reason that all the males genetically above that animal pass away or aren't able to breed, then this male all of a sudden becomes the most valuable male. So currently, right now, he is extremely valuable to us in terms of genetics, and that is why he's in a breeding situation. But it is getting to the point where we have to shut down that breeding pretty soon, and so we're looking to try to expand the program with other zoos that are interested in yellow-footed rock wallabies. That's definitely one thing. We've looked at alternative management styles, i.e. the bachelor groups, and we're still trying that. What we found with the bachelor groups is that I guess it depends more on the personalities. So you can have 2 males that might do well, but if you throw a 3rd one in there, he might be the bully of the group, and we might have problems that way. So it just varies with the personalities, and so that's why we look at different management styles for that. Yes?
Your ultimate goal is to breed enough to return to the wild?
That would be the ultimate goal,
So
yeah.
why don't you use some of these excess males as kind of a practice run just to see what type of management style would actually be needed to start successfully reintroducing them into the wild? Because I realize that when you start to do that, there's a big fall off on losing animals within a short period of time, and maybe they can just start learning some of the intricacies and reintroducing them to the wild with the males that are,
Love that idea. That would be an ideal thing to do. I'll be honest with you, is that actual reintroduction programs are very difficult. It takes a lot of effort, and it takes a lot of coordination with the state or country that's getting the animal back. So on a very rare occasion, we're actually able to import yellow-footed rock wallabies to keep our genetics as diverse as possible. Getting them back to Australia is proving to be difficult at this point, because the last thing you want to do is introduce any sort of captive disease back into the wild. And so at this point, Australia hasn't identified a program to get them back into the wild, although they know they eventually want to do that. And so that's probably our stumbling block right there, is working with the country of Australia. Yes?
So, is 50% about the ratio that you would expect? Or the percentage you would expect for males? You said 50%.
Yeah, I think the correct percentage is supposed to be 51%. For some reason, our statistics have showed 59% males. I don't know what your experience is.
I think it also just depends on the age distribution. You don't want 50% male and female if 100% of those males are geriatric and all the females are subadult. So you can't always say it has to be 50-50.
But with a natural breeding, though, wouldn't you would expect 50-50, or is it the ratio is slightly skewed toward males anyhow, right?
I think it's all species specific, and it all depends on their environment and how they respond to that, whether or not they're going to produce more males than females.
That's another manipulation. Is how do you manipulate the environment to shift the ratio of offspring from males to females?
I don't know that. Can you do that in wallabies? I mean, you can do that clearly in reptiles with incubation, but I don't know if you can do that in wallabies, can you?
Well, I know about wallabies, but I don't know that you want to, but we know that in some animals, in times of stress or drought or low nutrition, you'll shift the ratio of males to females. It depends on the environmental nutritional status. So maybe these are all really maybe they're overweight, I don't know, but it's something to look into. I don't know how drastic you have to shift the environment to shift the ratio. But it's been shown that populations do shift their ratio of males to females depending on the environmental setting.
So does it go more male or more female in low resource settings?
I can't remember.
I think it's male.
I think at low resources males, but I'm not sure. But it does shift.
We've never considered that with these guys. We'll have to look into that. That's a great option. Any other questions? Yes. Sure.
A bit unrelated, but related. We were talking earlier about how elephants are getting pregnant at a younger age, as opposed to the age that they would get pregnant at in the wild. Do you use contraception with elephants?
Well, they're reaching puberty.
Yeah. It has been done, but it's really not. Right now, the captive population is such that there's so few individuals that every one of them is valuable, that contraception is really not really looked at in terms of it. But they are looking at it not in terms of preventing breeding, but like what Pierre presented is the repeated cycles, and that becomes a problem as the female ages. So preventing those repeated cycles and producing something like the deslorelin, where it's mimicking progestins, and that you're going to suppress follicular growth for a certain period. But I don't think it's been 100% successful yet.
But it was based on injection of PZP injections too.
That's what they're using in elephants.
Well, that's been shown that it works. Yeah, in elephant.
Do you know when they copulate? Is there any way you can tell if they've copulated or bred?
No, we cannot tell. The only way we can tell is when the female becomes pregnant. We'll do what we call pouch checks as per the Australian protocol, where we'll grab the females, we'll look in the pouches to see if there's a joey.
Because David will know this, but I guess with PBS television, something about the acidic ratio, the pH of the vagina will influence whether or not the male chromosome, the sperm with the male chromosome in it will survive or not. So there's acid-base balance, but then you need to know when they were bred to influence the survival of the sperm.
I don't think we're near that close in knowledge on these guys yet.
Well, or you can inject spermicide also into the female vagina during the copulation period. That could be also one possibility.
Cheap and dirty.
Cheap and dirty.
Okay. We can look at it that way. We hadn't thought of it that way too.
You know,
That
or
would be an
vaginal
option.
sponges also impregnated, soaked with spermicide. That you can leave. I mean, but that's why. Okay, so anyway, in any type. So let's go back to the basics, huh? Because we come from the same school. You always need to have a really basic knowledge of the reproductive physiology of your animals if you want to try assisted reproduction or even contraception. So I think you need to have an armada of interns, young vet students who could study, watch those Tama Wallaby, 24/7, or you can install also the Wallaby cam, and so you can follow their behavior and make sure you will probably see some patterns at some point. So when they behave like that, that's their period of copulation, so that's when they breed. So that's probably, and then after that you can intervene, and probably before you can do this type of manipulation of, or you put something in the pouch also, or something into the vagina. I don't know. I mean, they're probably, but I think that's the key, because that's the way we've been, making progress in other species, is to know really the basics of the reproductive biology first, because I know that this laureline is really popular and it's been tried in so many different species, but we know also that even if it works in a species, then after that you're going to have individual differences. We know in cheetahs, for example, that it's a disaster for some of the females also, because they never come back. And that's what you have here. So.
Yeah, generally animals in estrus will increase their activity level. So just a pedometer or some telemetry on the female might give an indication that she's receptive at that time, possible. But that gets back to studying the basic behavior of the animal very thoroughly in physiology.
Excellent. Great idea.